Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your host, and as usual in the ghost mode, Mohit Jain. The process, the pattern we have already discussed in our first part. Link is there in the description below. Please go through it. So without wasting any time, let's start now. Interesting take today is a mix from algebra, function, series, geometry, let's see, and we don't know where we would be able to use it, but these kind of questions are asked. Try to use it. Okay, so let's take up the first one. For an equation 2 to the power x plus x minus 8 equals to 0, find number of real roots. How many real roots are possible for equation 2 to the power x plus x minus 8 equals to 0? Pause, give it a try. The situation here is we need to find how many real roots of the given equation are possible. Now, before knowing how to solve this, we are not supposed to find the value of x. We are just supposed to find that what can be the value of x and how many real values of x we can find. Okay, first, how we will plot y equals to a to the power x if we are plotting it on a graph paper. It will be simply a graph like this. And this point would be x0, then y is 1. And what will be the graph of an equation of a straight line like x plus y, or sorry, x by a plus y by b is equals to 1? This will be something like this, where this point on x-axis is a comma 0 and point on b y-axis is 0 comma b. Intercept form. Now if we look carefully, this particular equation can be broken up into two parts. Let y1 is equals to 2 to the power x and y2 is equals to x minus 8. Or if I want to equate these, can I write this as 2 to the power x equals to minus x plus 8, then y2 we will take as minus x plus 8. Now from this relation, y1 is equals to y2. These kind of situations should always be solved with help of graphs. Now we have got two graphs, exponential graph and a straight line. So if I plot this on a graph paper, first one is y1 equals to 2 to the power x, we'll get something like this. This is y1. And the second is a straight line where y2 is equals to minus x plus 8. That means y2 plus x is equals to 8, which falls into this format. That means this will be something like this. At what point they are meeting, we are not concerned about that. We are concerned about only how we can draw this on the graph paper. Now this is y2. According to the given situation, y1 is equals to y2. And here we can see that y1 and y2 are intersecting at only one point. There is one point of intersection. That signifies that there is one real root. And there is only one real root of the given equation, and that is the solution. Okay, let's do one more. Find the number of integral solutions of x for which mod of x minus 2 is greater than 2 times mod of x plus 3. Give it a try. First we'll try to identify this with help of graphs, and then we can build some short analysis based on graphs, and once if you see these kind of question you can answer it very easily. Let's drop it into two parts. This is y1 and this is y2. So we have got y1 equals to mod x minus 2 and y2 equals to 2 mod x plus 3. So let me put it on a graph paper. First one is mod x minus 2. That means it will start from here. This is x equals to 2 and then 45 degrees. This one is y2 equals to 2, or we can write this as 2x plus 6 for an instant, suppose, to find the value of x. If I put this as 0, x will be equals to minus 3. So this will start from this point something which is x equals to minus 3, and it shall go like this, suppose. That means these two graphs meet at 2 points, A and B. Our job is just to identify these 2 points. That's it. Now this particular branch is positive. This is 2x plus 6, and this particular B C is negative, that is minus 2x minus 6, and this B A D is negative of y1, that will be minus x plus 2. So now to find A, I will equate 2x plus 6 is equals to minus x plus 2. That means 3x is minus 4. X is equals to minus 4 by 3. That is minus 1.33. So this particular point A is x equals to minus 1.33. To find the value of B, I will equate minus 2x minus 6 with minus x plus 2. So if it comes here, it is x, and this will be minus 8. X is equals to minus 8. At B, x is equals to minus 8. So that means the integral solution lies from this particular point to this particular point, and we just need to identify that how many values of x are there between B and A from minus 8 to minus 1.33. So how many we have? Minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, and minus 1 also. Okay, let's see. This is minus 1.33. Is it applicable at minus 1? If x is minus 1, minus 1 minus 2 is minus 3, that is 3. Now minus 1 we can't take because we need to go till minus 1.33. Minus 1 is obviously greater than this. So how many values of x we are left with? 1, 2, 3, 4, 5, 6. On this particular line there are only 6 values of x which are applicable, and we are looking at y1 is greater than y2. This is y1 and this is greater than y2, which is, that means it will be on the upper side. It will be on this side. Solutions, and these kind of integral solution you will find on the given range. So 6 integral values of x are possible. 6 integral values of x are possible. Whenever you have got this kind of question, just you need to identify that which two branches of these mod functions would be intersecting, and on that common part, on that boundary part, find the integral solutions. Now based on the concept which we have seen in number 2, please try to solve this. Find the number of integral solutions of x for which mod x plus 2 plus 8 is greater than twice of mod x minus 2. Give it a try. Okay, let's use what we have learned in question number 2. We need to plot these two. So the first one is y1 equals mod x plus 2 plus 8. If x is minus 2, where the mod becomes 0, y will be equals to 8. So it will start from this particular point. So let me use this. This is minus 2 comma 8, suppose this point. Then we will have something like this for y1. For y2 equals 2x minus 4 or 2 into x minus 2. If I take 2 into mod x minus 2, it will start at x is equals to 2, y is equals to 0. This point 2 comma 0, and we will have graph like this. Clearly it can be seen that they are intersecting at 2 points. We need to identify these 2 points again, A and B. Now first, this right hand side of y2 is positive, that would be 2x minus 4, and this side would be negative, minus 2x plus 4, and this particular arm or ray is a positive of y1, that would be x plus 10. So to find the value of A, I am equating x plus 10 with minus 2x plus 4. So what I get, 3x equals to minus 6, x equals to minus 2. For B, I am equating x plus 10 with 2x minus 4. So here 2x minus x is x is equals to 14. So from minus 2 to 14, this range, the integral values on this particular ray is the number of integral solution for which this particular thing holds good. This is greater than this, that means this will be the shading point, and we are looking out for what we call is corner values. So from minus 2 to 14, we have got minus 1, 0, 1, 2, 3 till 13. So 13, 14, 15. There will be 15 values of x for which the inequalities hold good. There are 15 values of x for which the inequality hold good. Okay, let's try one more. Find the number of real roots for the equation 2 to the power mod x minus 2 is equals to mod x minus 2 plus 6. Now, first, if I have got y equals to 2 to the power x, I know this is the graph. And if I have y equals to 2 to the power minus x, this is the graph. Exactly mirror image of this. And when we have y equals to 2 to the power mod x, that means this particular portion and this particular portion will not come, and then this will be the graph for y equals to 2 to the power mod x. Here we have got y equals to 2 to the power mod x minus 2. So whatever it is x minus 2. It will shift a little bit upwards. So we take this portion and this portion. This will be our y1. Now y2 is mod x minus 2 plus 6. We know that x will be equals to 2. Then y2 will be equals to 6. We have got this value 2, 6 something like here, and from here we will have V-shape curve. It will meet graph of y1 at 2 points. There will be 2 intersecting points. Therefore, equality holds at 2 values of x. We can say 2 real roots are possible for the given equality. Okay, let's take one more. Question number 5, I think, correct? Question number 5 है ना? Okay. How many real solutions of x are possible for the equation? ध्यान से देखना. x square minus 4x plus 3 to the power x square plus 3x minus 4 is equals to 1. Give it a try. It's not graphical. Give a logical try. Okay, as discussed that we should be using some logic. And how the logics to be used? If we look here, it is quadratic raised to the power of quadratic, which is equals to 1. That means a to the power b is equals to 1. When it is possible? It is possible when a is equals to 1 and whatever be the value of b. 1 raised to the power 0 or positive or negative will give us 1. So if a is equals to 1, a to the power b will be equals to 1. So here what we get, x square minus 4x plus 3 is equals to 1, or x square minus 4x plus 2 is equals to 0. So we will get two values of x. Values of x would be minus b, that is 4 plus minus root over b square minus 4ac. 4 into 2 is 8 by 2a. So it would be 4 plus minus root over 8, that is 2 root 2 by 2. So what we are getting is 2 plus minus root 2. Okay, these two are real values. Now, isn't it this also possible that b is equals to 0 and a is not equals to 0? A is not equals to 0. A can be anything. Negative, positive, whatever. But b is equals to 0. So if we make b equals to 0, x square plus 3x minus 4 is equals to 0. What we will get? X plus 4 into x minus 1 is equals to 0. Yes? X square plus 4x minus x minus 4. So here we'll get x is equals to minus 4 and x is equals to 1. Now, it is also taken into consideration that x square minus 4x plus 3 should not be equals to 0. So if I put x equals to 1, I'll get this as 0. That means x equals to 1 is not possible. If I put x equals to minus 4, 16, 16, it would be 3. It would be not 3, 16, 16. It would be more than, it would be 35 and not equals to 0. That means if b is equals to 0 and if a is not equals to 0, we get one more value of x, that is minus 4. Where power x square plus 3x minus 4 is equated to 0. Now, one more condition is possible, that a is equals to minus 1 and b is even. If a is equals to minus 1 and b is even, then also we'll get a to the power b is equals to 1, isn't it? So now this time I would be equating x square minus 4x plus 3 is equals to minus 1. So x square minus 4x plus 4 is equals to 0. This will be x minus 2 whole square equals to 0. Here we'll get x is equals to 2. Now b, that should be even. X square plus 3x minus 4 should have an even value when x is equals to 2. 4 plus 6 minus 4 is equals to 6, which is even. That means it is applicable. X is equals to 2 is also one of the value. So here what we can see, that we have got 4 real solution of x for which this particular condition is possible. First value is 2 plus root 2. Second is 2 minus root 2. Third is x equals to minus 4. And the fourth one is x is equals to 2. 4 real solutions. Nobody is asking about what is the value, but we have to calculate these values so that we can check the condition which we are considering. First condition, second condition, third condition. Logic and do it. So thank you everyone for participating. This is Mohit Jain signing off. I'll see you soon.